All right, so section 4.4, we're talking about introduction to trigonometric equations. So we've talked a lot about trig, right? We've talked a lot about sine, cos, tan. We've talked a lot about the unit circle and how to find exact values. We're going to talk about that again today, but it's going to be in the context of equations. So we're going to be looking at trig equations. My first question to you here is, how do we solve a regular old, plain old algebraic equation? So if I had something very simple, let's say I had 3x plus 7 is 16. Okay? Let's say here's my simple algebraic expression that you learned way back in grade whatever. You were doing this in grade 6 or 7. But what we're trying to find is x. And the method that we use to solve this is to isolate x, right? We get x all by itself and positive, and then whatever over here, whatever's left over here is our answer, right? That's what we do. So, we do that here. We subtract 7 from both sides. We get 3x equals 9. Then we divide by 3, both sides, to get x all by itself. And here you have x equals 3. Okay? So that's a simple algebraic expression, one you've been doing for years and years and years. Now, if we talk about a trig equation, all right, sine of theta equals 1/2, let's say, then up to this point, I've taught you, and you've been doing in math, to solve for an angle theta. What we do is we take the second function of sine on both sides, right? And this is, again, what we've been learning, what you've learned so far in math. And that's how you isolate for theta. Okay? So let's just get on our calculator and see what we come up with if we do this. On my calculator, I'm going to want to get into mode here. Yeah, may as well do degrees. That's totally fine. All right. So let's clear that screen. Second function sine, right? Because if you look back over here, the inverse of sine times sine, that cancels out. That's why we do that. And then this is what you have left on the other side. This is how you would do that on your calculator. So sine to the -1 of 0.5. What angle is that? 30. Okay. Let's see if that makes sense in context of our special angle triangles. Okay. So here's 60. Here's 30. We've got 1, 2, root 3. Sine of 30 should be opposite over hypotenuse 1/2. That makes sense. 30 degrees. Okay. So this is what we've done so far. Now, the only issue is, okay, we have a couple issues. One of the issues is sometimes we don't want to have an approximate answer. This is an exact answer, okay? But sometimes we don't want to have an approximate answer. We want to have an exact answer. And of course, we use the unit circle to find out our exact answers, right? So in order to use the unit circle, we're not going to be doing this anymore. We're not going to be taking just the calculator and second function sine. Okay, now you may have calculators that will give you exact answers in radians and such, but we're going to be using the unit circle. So if I wanted to do this in radians, let's just see, what is this in radians? Well, take my mode here. Let's go down to radians, and if I do the exact same thing, let's do that entry again, then I'm going to get this. Okay, so if you write down this answer, and if you use all these decimal places, even if you use all the ones that show up on your screen, that is still an approximate answer. See that? So in pre-calculus 30 and in calculus, we are A, interested in exact values, and B, we're interested in radians. Radians is huge, not degrees. So if we're doing this, and I want this answer in radians, okay, then the calculator bit is not going to cut it. What we want to do is we want to go back and look at the unit circle right here. So I have one from the last lesson. And what we do in this case is we look at this and we say, what's our original question here? It looks like this. Okay? Instead of isolating for the variable, like we used to do, we are now going to stop at this point that says sine of theta equals 1/2. You're going to kind of stop there. Okay, once you've got this all isolated by itself, you're going to stop there. And then you're going to use the unit circle to connect this so we have an exact answer for theta. So use, oh, I can't write today. Use unit circle to solve for theta. Okay, so that's what we're going to be focusing on here today. So let's go back up to the unit circle. And what I'm looking for is the angle that is associated with a sine value of 1/2. So a sine of 1/2, if you look in the first quadrant, what is this? It's cos, right? And then sine, right? Alphabetical. So, oh, there's cos of 1/2. No, not what I'm looking for. Oh, here we go. Sine of 1/2. That makes sense? Sine of 1/2. So you find this sine of 1/2 and you say, there it is, pi over 6. That's what my calculator tried to tell me, pi over 6. But it didn't do a very good job because it's giving me a repeated decimal. Now you may be thinking, Mr. Maxwell, I have a special calculator that can give me, you know, the exact value in radians. Yeah, you might, but you're not going to be able to use that calculator forever. And you need to understand kind of where this is on the unit circle. That's sort of the goal using the unit circle here. So we look at this and we say the answer is pi over 6. Okay, from the unit circle. That's an exact answer. Now, if I gave you this and asked you to solve for theta, you actually have a problem. And not the fact that you have to look at the unit circle. That's not your problem. The problem is this is not the only answer, is it? Okay? You should be shaking your head right now and realizing that, hey, I understand the unit circle, that it is a periodic thing. That means, guess what? It goes all the way around and all the way around again. Oh, and it goes the other direction too. Oh yeah, and it keeps going that way too. So there's not just one answer for this. Right? Where else does 1/2 show up on this unit circle? Do you see positive 1/2 in the sine position anywhere else? Oh, over here. So you see this, and you say, guess what? Maybe this is an answer too. And actually, the reality is that it is an answer as well. So we could have also, or theta equals 5 pi over 6. Now, is your calculator going to tell you that? No. What did my calculator tell me? Just that. So there's another limitation of the calculator. You're only given, the calculator, most calculators just spit out the acute angle, the first quadrant positive angle when you ask stuff like this. So the questions are not just going to say, what's the angle missing theta here? It's going to say, what is this angle between 0 and 2 pi radians? So you're going to be accompanied by this sort of restriction. And that means that you need to list all possible answers between 0 and 2 pi, or within one full rotation. So that's where we would say pi over 6, as well as 5 pi over 6. All these other ones are negatives, see? So in this case, this is what this whole section is about. You're going to be getting a question just like this, and you're going to look at the unit circle, and you're going to say theta is pi over 6 and 5 pi over 6. There's two solutions. Now, if it just asks you for a general solution, okay, that's specific solutions within this domain. That's the domain of the variable. If it asks you for a general solution, you could say something like this: theta equals pi over 6, and then how do we write coterminal angles? Remember how we do that from 4.1? What was it? Okay, well, you said plus or minus 360 n, except we're dealing with radians, so you're close. So if I got radians as my answers here, so yeah, so plus or minus 2 pi n, or I don't know if they do the minus because n could be an integer, but so pi over 6 plus or minus 2 pi n, I would be fine with that. And in 4.1, Yeah, they say plus or minus 2 pi n. N is just natural numbers, whatever. Okay, so that's the general solution. Here are your specific solutions for this given domain. Okay, so that's basically this section, really. That's an introduction. We're going to do some more examples, and why don't we just write down just some notes to formalize this, okay? All right, so this is what I would suggest as kind of an outline of what we've talked about here so far, and moving forward what we're going to be doing. To solve trig equations, we use the exact same methods as solving regular algebraic equations, with the exception that instead of isolating for the variable, like we did in the above example for x, we isolate the trig function only that contains the variable. Then we'll use the unit circle to give exact values of the variable or of theta. And then we have to also take into consideration the specified domain. Now maybe put that in brackets actually. Within the specified domain, if applicable. All right, so we're going to do some more examples, and we're going to get through this. Awesome. Okay, so example 1. Let's do example 1 here. It says this: 5 times sine theta plus 2 equals 1 plus 3 sine theta. And we're looking for values for theta between 0 and 2 pi, so within one sort of revolution. All right, so this is an example of a trig equation. How do I know that? Well, I have trig and an equation. That's pretty straightforward, isn't it? So that's your clue that this is a trig equation. All right. So what it says is, it says we use all the same methods as solving algebraic equations. What I mean by that is you can isolate certain things or move certain things around in the equation the exact same way that we did before. An example, of course, would be, let's get the sine terms. These are like terms, aren't they? So let's get those over to the same side. So I'm going to subtract 3 sine theta from both sides. That's a method that I would use for solving an algebraic equation, right? To move common terms to the same side. So 5 sine theta minus 3 sine thetas, I get 2 sine theta now. I'll leave everything else alone for now. And over here, those, of course, completely cancel out. They're not divided by, I'll get rid of that little line here. All right, so everyone with me so far? It's pretty easy, right? Okay, so I want to get sine theta by itself, okay? So I want to isolate the trig function that contains the variable. So, yeah, I'm going to do this. That's my next simple step, and I'm going to show every step just so there's no gaps here, guys, okay? I'm almost done. I want to divide this 2 off now. So sine theta, that's what I'm looking for. Just the trig function by itself and positive with no other coefficients other than 1. It's just by itself. And here I've got negative 1/2. So this is very similar to our first example, right? We're not done yet. We want to find out what theta is, but I'm going to highlight that because that looks exactly the same as our example up here, doesn't it? Except instead of positive 1/2, we've got negative 1/2. So we're going to do the exact same way. So let's look at the unit circle. Let's go back up here to our unit circle right here. I'll erase all this jazz. Yeah. And so let's use a black marker there. And okay, so I'm looking for, what am I looking for? Sine, which is the second coordinate point, right? The y value of each coordinate. So that's not. That's positive. Okay. What about, oh, here we go. Got a negative. Let's see, anywhere else? I'm just cruising around here. Oh, what's this? Is that one? No, that's cos. Good job. So here's another sine and positive. So it looks like these two. Does everyone see that? So what are those two? Well, that is this, 7 pi over 6, and this, 11 pi over 6. Your calculator's not going to give you those values, right? So unit circle. So we go back, and again, you have to check, is this all within one complete rotation between 0 and 2 pi? Yes. And that's everything that I see in one complete rotation. So I go back there, and I say, you know what, I found it. It was, now I've forgotten, 7 pi over 6? 7 pi over 6 and 11 pi over 6, is it? So those are our two solutions to this trig equation. Any questions? Yeah. Okay, if you're using the general form, if it didn't give you this domain and it just said general form, well, okay, this is going to be a bit tricky for general form. We can talk about it right now, though. So we go back here, okay. How do you do general form for these two answers? Okay, well, what you could say, right, is you could say, this plus or minus 2 pi n, and this plus or minus 2 pi n. That's totally fine. That would be probably the easiest way to do it. Just list them both, and then just plus 2 pi n. So the best thing, the easiest thing to do would be just, you can do this. Pi over 6 plus or minus 2 pi n, and 7 pi over 6 plus or minus 2 pi n. And like I say, if it comes up again, I'll explain how you could make it a little bit easier. But these ones are kind of, they're not related by, just adding pi radians or adding pi over 2 radians. It's so that's the best way to do that. If it was general, okay, general solution. Okay. So let's do another one here. Another question. Let's say we have sine squared x minus 1 equals 0. Now what you want to remember with this question right here is that the 2 right here, that really means sine x times sine x, right? That's the same as sine of x all squared. But in avoiding the confusion that might arise by thinking, oh, someone might think this is sine of x squared, they write the 2 there. So this position for the 2 can only mean that the whole trig function is squared. So just got to remember that. All right. Oops. So what do we do here now? Well, we could say, all right, let's solve for sine of x. And you could take the square root here. And you get sine of x. Remember, this is what we're looking for right here. When you take the square root of something, remember what you have to do is you have to do plus or minus. Right? So when you take the square root of 1, you have to do plus or minus 1. We good there so far? Okay. What's another way you could have solved for x given this? Anybody see another way you can actually do it? This is fine, and we'll continue on with this. Does anyone see another way you could rewrite this or solve? Does anyone see a difference of squares here? Maybe some of you saw that, maybe not, but you could write it like this. Zero. See that? That works too. And then you let each one of these equal 0, you get sine x equals negative 1, and you get sine x equals positive 1. Isn't that the same as what we have over here? Okay, so either way you look at that, you can use all the same algebraic methods, no problem. When you get to this point, now of course we're looking for x values for the angle where sine is plus or minus 1. And let's see, do they have an interval they gave us here? Yeah, 0 to 2 pi. Okay, so let's just write that down. 0. So we're looking for just within one full rotation. Again. All right, so unit circle. Where's our unit circle? Okay. So where do we see sine is 1 or negative 1? Sine is the second, right? Okay, what about here? See that? And negative 1 down here. So what are our two answers? Pi over 2 and 3 pi over 2. See that? That's how we solve. Look at the periodic, the unit circle. So pi over 2 and 3 pi over 2. So x equals pi over 2 and 3 pi over 2. Done. All right, so I'm going to just ask you, how does this change if I say this? I'm going to change this domain. Okay, same question, but I'm going to change this right here. What if I say from negative pi to 5 pi? Wow. Okay. So that changes things a bit, right? Now we got to really think about this. Of course, we're going to use our unit circle, but from negative pi to 5 pi. Okay, so I'm just going to grab this unit circle here and bring it back down so we can see it on the same screen if possible. Okay. Okay, so from negative pi to 5 pi. Okay. Right here. Okay. You guys with me here so far? You good? All right, so I have pi over 2, and I have 3 pi over 2. Okay. What you have to consider now is here's 0, so I got to stretch back, I got to walk back, and I got to start here. Okay? And I got to now go forward. And look I hit this right here. I hit this right here where sine is negative 1. So if this is negative pi right here, what is this angle? Negative what? Sorry? Negative pi over 2, yeah. Because see, it's 90 degrees back. Okay? So this is negative pi, this is negative pi over 2. So x equals negative pi over 2. That's one of our answers. Right here. And then I go around and then I hit what? What comes next? Positive pi over 2. Good. And I got to go all the way to what? 5 pi. Oh my goodness, okay. So here is now 1 pi, nothing. Over here is, oh, okay, so I need to write down this one, 3 pi over 2. Thank you. And then I keep going. There's 2 pi, right? Okay. Now what is this going to be? This is not just pi over 2 anymore. This is 2 pi plus another pi over 2. Okay? So we've got 2 pi plus pi over 2. What does that equal? How do I write that? Well, 2 pi really is 4 pi. 4 pi over 2. So what is this? 5 pi over 2. Is that in simplest reduced form? Yep. So guess what? Write that down. Not done yet, but once again, let me just... I'm seeing a lot of really strange faces right now. So I'm going from negative pi, I'm going to go here, and I need to write down this angle. Got it. That's negative pi over 2. I'm going to keep going around to back to 0 and to positive pi over 2. There we go. Got that one. I keep going around the circle until I hit this again at 3 pi over 2. Got that. Now I've got back to 2 pi. So I'm at 2 pi now. I need to keep going all the way to 5 pi. So when I go around here, I hit another value. Because remember, unit circle, cyclical, right? Periodic. So it is kind of like a periodic table. But this is now 2 pi plus another pi over 2 radians, which is 5 pi over 2. With me? Okay, so 2 pi, this is now 3 pi, and I'm going to hit this one again. Okay, so this is now I'm at 3 pi. What is this? What's 3 pi plus pi over 2? 3 pi plus pi over 2. Well, that's 6 pi over 2 plus 1 pi over 2 is 7 pi over 2. Does that make sense? Am I right there? Did I do that right? Okay. So there's a lot to keep track of, right? But we're at 3 pi, and now we're at 4 pi, and now I got to go all the way around to here again, and I pass this one more time. So at 4 pi plus pi over 2. What's 4 pi plus pi over 2? Well, that's going to be 8 pi over 2 plus pi over 2 is 9 pi over 2. And then I hit 5 pi here, and I'm done. And you've got all of these answers right here. Doesn't that just make you excited? Isn't math amazing? Woo! You guys need to get a little bit more excited, in my opinion. Okay. Anyways, now it may not be the the most fun you can think of doing on the weekend or anything, but is this something you understand? Think you could do that? Maybe. Okay. It's going to take a little bit of thought, a little bit of work. The summary here says the key ideas in this section are to solve trig equations algebraically. You can use the same techniques as used in solving linear and quadratic equations. Okay, so talked about that. When you arrive at sine theta or cos theta or tan theta, where a is some real number, then we use the unit circle for exact values of theta. The inverse trig function keys on the calculator will give us approximate measures, right? Now, girls, what we need to remember though is that if we use our calculator, it's only going to give us that first quadrant angle, right? So if you have, if you have a domain, you have to think about that. You're only given the first quadrant angle, so you're going to have to work with that. So that's where we use reference angles to find all the solutions in the other quadrants if we're given some kind of specified domain. All right, so if we didn't do an example with cosecant, but if you get cosecant, if you get something like this, cosecant theta equals 2 over root 3, let's just say, what you have to realize is this is 1 over sine, isn't it? Right? Equals this. So sine theta, you're going to move it to sine theta, and that equals root 3 over 2. Then you can go to your periodic table. So with trig equations, just realize what they equal, and then, again, manipulate it till it's one of the primary trig functions. And then general solutions, find the solutions in one positive rotation, and then use the concept of coterminal angle. So plus or minus 2 pi n, or plus or minus 360 n. All right, and there's your lesson for 4.4. I'll give you your assignment here, and good work today.